Problem 15.88 involves a rod AB that can slide freely along the floor and along the inclined plane over here. Denoting by the v sub a the velocity of point A down here, and it's to the right, derive an expression for the angular velocity of the rod and the velocity of NB. We are to use the instantaneous center of rotation type of approach here. And so when we do that, we look at the velocity of A is this way, and the line perpendicular to that through A is a line that runs vertically on the page. And then over here, V sub B is going to be going upward like that, and so a line perpendicular to that is perpendicular to that incline. An extension of it in this direction is not going to cross this line over here, but an extension in this direction right here will cross that line at point C, and that's going to be where our instantaneous center of rotation is located. Note on the drawing here that this angle is beta, this angle is theta. This angle right here is also beta, which means this angle right there is 90 minus beta, which is this is 90 minus beta, which makes this angle beta. And this angle, that makes that angle right there beta as well. If we look at the, I'm going to label this point over here D. The distance from B to D right here is just simply L cosine theta, so that's that number right there. The tangent of beta right here can be written as this distance right there, which is the L cosine theta, and divided by this distance right here, which is the position, or LC slash D slash C, excuse me. And so we have that, so L sub D slash C is equal to L cosine theta divided by tangent beta. Now the reason I wanted that distance right there is because I'm looking for this total distance from C down to A, so I can multiply it times the omega, whatever that total distance is, multiply it times omega, and I got V sub A. Now notice that the way this rod is rotating, it's a positive contribution, so omega will come out to be positive. So omega times the distance. Now what is that distance? Well, it's this distance right here plus that distance right there, and that distance is L sine theta right here. And this other distance is L D slash C, which we've got expressed right there. So we saw for omega, it's going to be VA divided by all of this. So the time you put this in here and factor out to L, then you're going to have a cosine theta over tan beta plus the sine theta right there. And you can simplify that down to right here by multiplying the top and bottom by tangent theta. And that gives you that. And then if we take the tangent theta and reduce it to a tangent beta, if we reduce that to sine beta over cosine beta, then I can multiply the cosine beta through here and end up with this expression, which is the cosine of beta minus theta, or it could be cosine of theta minus beta. It doesn't make any difference. This is a positive number one way or the other. And as long as theta and beta are less than 90 degrees. So this right here is the answer for the omega, and it's positive k direction. The velocity of B is going to be an omega times this distance right here. With omega coming out of the plane of the board and that distance crossed into that distance right there, I'm going to velocity of B is up the incline. So it's going to be omega times L sub B slash C, which is that distance right there, which is omega then, and L sub B slash C. If we get this distance right here, we can do it by taking a look at the sine of beta. The sine of beta would be this distance divided by that side right there. So this side right here would be equal to this side divided by sine of beta. Well, that's L cosine theta for this side right here divided by sine beta. And so when you do your plug-ins right there, you'll end up with VA cosine theta over cosine beta minus theta. Note the approach that I promote in class a lot is this one right here, where you write the velocity of B is equal to velocity of A plus the velocity of B with respect to A, and so the velocity of B is in this direction right here, and it's cosine beta I plus sine beta J. And notice it doesn't matter what direction it is, it'll all come out in the wash here as we put in that V sub A is a positive number in the I. And then so V sub A is that, V sub B slash A is omega crossed into R sub B slash A. R sub B slash A is a vector of length L and runs in that direction there, which is a cosine theta I plus sine theta J. And so if you look at the I parts of this equation, V sub D, V sub B cosine beta right there, and then V sub A right there, and over here it's going to be the K crossed into J to give me a negative I, so I'm going to have omega L and a sine theta with a minus sign. Then the other one's going to be V sub B and a sine beta, And here, this is going to give us a positive contribution there. So we're going to have mega L cosine theta. If I call that equation 1 there and this equation 2, if I'll take 2 and divide by 1, if you'll notice there, then doing so, the left-hand side just simply becomes tangent beta, and the right-hand side becomes mega L cosine theta divided by b sub a minus mega L sine theta. And so when you simplify that down to solve for omega out of that, you get an expression that looks like this, which is exactly what we had up here.